So let's do some examples to illustrate the definition. Blue pen. Okay, this series here. So it is summation n equals 1 to infinity of -1 to the n. So that is -1 plus 1, -1 plus 1, -1 plus 1, and so on and so forth forever and ever and ever. So what is the sequence of partial sums? So this would be S2 here. And if I take another term, I get S3. If I take a fourth term, I get S4. Oopsie daisy. So S2 is 0. S3 is -1. S4 is 0 again. S5, I would be including this term, so I'd go back to -1. So I'm looking at this sequence of numbers here. Does it have a limit? No, it does not. Okay, it's alternating forever. Just goes back and forth between 0 and -1 forever and ever. So there is no limit. It's not approaching anything. That's a funny looking brace. Ooh, much better. So therefore, lim Sn does not exist. So what do we say? We look at our definition. Up top here. So the second sentence, if Sn diverges, then our series is a divergent series. So that's our conclusion here. Therefore, this series is divergent by definition. Okay, next example. We're going to look at this guy right here. So what I'm going to do, what am I going to do? I'm going to look at the summand and say that looks like partial fractions. A over n plus b over n plus 3. And I'm not going to show my work, but we will actually get, I'll actually get this. So as a note, I'll just put, I did partial fractions. Yeah, that works. So this helps us, I promise. Give ourselves some space here. This helps us. How does this help us? Well, let's start writing out some terms here. S1 is just the first term. So just this guy in the rectangle with 1 plugged in. So I get 1 over 1 minus 1 over 4. That's 2. We'd have 1 over 1 minus 1 over 4 plus the next term, which is this guy in the rectangle with 2 plugged in. S3. This is a bit tedious, but I have to write out many terms here so I can notice any pattern that is emerging. You know what? I don't see anything yet. So let's keep going. S4, 1 over 1. Yes, tedious. This is really tedious, but I think it's all going to pay off right now. Next term is 1 over 4 minus 1 over 7. And if I'm paying attention, I will notice a cancellation. This term, minus a quarter, cancels with plus a quarter. Now, if I think about what's going to happen with S5, I believe that this minus a fifth is going to cancel with a plus a fifth right here. So let's try to figure out what's happening. So I'm going to write down S n. Let's see if I can't figure out what's going on. Now I'm going to go plus dot dot dot, and I'll take it up again down here, plus dot 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 plus. Now I'm going to write the last 5 terms. So I wrote the first 5 terms here. So why don't I write the last 5 terms down here? 5 is, give myself a bit more space. 5. Why 5? Well, I'm trying to write out explicitly as many terms as necessary to understand what's going on. Okay, let's go green here. Now, when there was a 4 here, my last term had a 4 right there. Oopsie daisy. So 4 and 4, right? So that tells me that because I have an n here, my last term should be 1 over n there. Now going back to the 4s, I have 4 here, and then I got 4 plus 3. Oops. So 4, and then 4 plus 3. So here I have n. So right here I'm going to have n plus 3. Now, what else? Let's look at S4 again. If I want to figure out what goes here, my second last term, well, just notice that the 4 and the 7, you just subtract 1 to get 3 and 6. So that's what I'm going to do to figure out what's going on in my second last term down here. So I'm going to go 1 over n minus 1, subtracting 1, minus 1 over n plus 2. And as I go from right to left, I just keep on subtracting 1. Okay, now look at what I wrote in red here. I showed some cancellations. I want to do that with Sn. So the quarter minus a quarter plus a quarter minus a fifth plus a fifth. So what do I conclude? I conclude that the sixth is going to go away, the seventh, the eighth, it's going to go away. But the 1 over 1 will survive, the 1 over 2 will survive, and the 1 over 3 will survive. Okay, at the end of my sum, what do I got? Looking carefully, I got plus 1 over n, and I got minus 1 over n. I got plus 1 over n minus 1 and minus 1 over n minus 1. And continuing this way, I make the educated and correct guess that this will disappear. This will disappear. This will disappear. So what survives? Sn is the 1 over 1 plus 1 over 2 plus 1 over 3 from the beginning of the sum that survive. Then at the end, you have 1, 2, 3 things surviving. And what is the limit of Sn now? Let me pause for a second. What have I done? I have taken a very complicated Sn, and I have done a whole bunch of cancellations. So we call this a collapsing sum or a telescoping sum. So let's write that down. This is a telescoping sum. Okay, like a telescope that you can extend or contract, depending on if you're using it or not. Now, the idea is that now that I have this nice simplified form here, I can say the limit is just the first 3 terms, because this circled part, the limit is 0. And if I do a common denominator, what do I get? It's going to be 6, and I get 6 plus 3 plus 2, and that is the 11 over 6 that I was expecting. Okay, pause and copy that. Pause, copy. Boop, 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 boop. And now I have an exercise for you to try. So try this exercise, and when I come back, I will give you the answer.